So we're in section 9.1 and we're going to talk about circles, chords, and arcs. So the first thing we're going to do today is talk about different parts of circles. So we know a little bit about circles. We want to talk about the different parts. We're going to name circles. With this little symbol. Little circle with a dot in it. So we're going to name the circle by it's a little circle with a dot in it and the point at the center. So if we have a circle here, draw a circle and our center is A, we would call this circle A. Or we could just use the word circle. So this means circle A. It's talking about the circle with A at the center. So that's how we're going to name them. And we'll talk about the definition of a circle a little later, and we've talked about it a little bit before. So the circle is all these points that are the same distance from the center. And we're going to use that definition a little later. So we're going to name some different parts of the circle. Some of them we already know. Some we haven't talked about before. So the first part we want to talk about is a radius. So on a circle, where does a radius, what part of the circle is a radius? To the circle, from the center to the circle, right? So a radius is a segment from the center to the circle. So we already know about a radius. A chord is a new one that we're going to talk about. A chord is any segment that has its endpoints on the circle. So it could be anywhere on our circle. And the third part that we're going to talk about, the segments, is one that we already know about, is a diameter. And what do we know about a diameter? Across the circle, but where does that diameter have to go? Could I go from here to here? Through the center. So the diameter, we're going to say a diameter is a chord, because its endpoints are on the circle, through the center. So those are our segments that we're going to talk about. So let's draw a little picture. Anybody have questions about the segments that we're talking about? So let's draw a picture of a circle with all these. I'll just put all the different points on it. I'm going to switch pages to draw the picture. So here's my circle. And there's the center P. So this would be circle P, or circle P. And we'll draw in some segments. So there are some segments in our circle. The segment that goes through the center is the diameter. This is a radius. And both of these are chords. Chord just has to have both of its ends on the circle. A diameter is a special chord because it has to go through the center. So there's what we're talking about with our segments. So these are things that go on kind of inside the circle. So any questions on our parts? So the other thing that we want to talk about, the other thing that we want to name, that we want to figure out some things about, is things that are going on actually on the circle, parts of the circle on the circle itself, not just parts in the middle. So we're going to talk about arcs. That's the next thing we're going to talk about. Major and minor arcs. So we'll do it like we did with the segments. We'll talk about what the parts are, and then we'll draw a picture. So an arc. An arc is just an unbroken part of the circle. Thank you. So an arc is any unbroken part of the circle. So we're talking about actually on the circle itself. We're talking about just a piece of the circle. The endpoints of our arc are on the circle. So we're not talking about a piece that starts on the circle and then goes off. So an arc is an unbroken part of the circle and its endpoints are on the circle. So one special kind of arc is a semicircle. Anybody have an idea of what we mean when we talk about a semicircle? Half a circle. So semicircle is half a circle, and that means that the endpoints of the arc that makes up the semicircle are on a diameter. So just to be a little more precise, we're going to say it's an arc with endpoints on the diameter. The diameter cuts the circle in half. So the semicircle is the arc with its endpoints on the diameter. So we have a half a circle, a semicircle. What would you guess then? We're talking about when we're talking about a minor arc. Half of the semicircle would be a minor arc. So what we're talking about when we're talking about a minor arc is any arc that's smaller than than a half a circle. So I'm going to say shorter than a semicircle. So any arc that's smaller than half a circle is a minor arc. We name a minor arc by its endpoints and a little arc symbol. So we would say arc AB. That's how we would write or name an arc. So this would be arc AB. One endpoint would be A and one endpoint would be B. And we'll draw a picture in just a minute. So if a minor arc is smaller than a semicircle, what are you going to guess about a major arc? Larger than a semicircle, smaller than a whole circle. So I'm going to say longer than a semicircle. And we name a major arc by its endpoints and one other point. So a major arc, I would say arc ACB. And when we draw our picture, what the C is telling us will make more sense. All right, so those are our parts. So let's draw a picture of a circle, and we'll label some arcs and semicircles, major arcs and minor arcs. Any questions on this part? Again, not difficult information, just some new vocabulary, new things that we're going to do to work with circles. So here's our circle. Let me move it over a little bit. And our center, we'll call it center P again. And I'm going to put some points on my circle, and then we'll label them. So this is circle P. So when you see the symbol circle P, this tells you automatically you know that P is the center. Circle P. So P is the center. So let's label some minor arcs. So I have a minor arc here. Minor arc EC. There are other minor arcs. I have minor arc BE, minor arc AB, minor arc AD, minor arc BC, lots of minor arcs. So I just decided to label one. We have we can talk about a couple semicircles. Semicircle DAE. So I start at one end of the diameter and go to the other end. So when I label a semicircle or a major arc, the first letter tells me where I start, the second letter tells me one point that I go through, and the third letter tells me where I end. So this tells me I start at B, go through A, and end at E. I could also talk about semicircle DCE. I can go around either direction and still half a circle.
Wait, is AC a semicircle, or like what way would you look at it? If it was, like, would it be major if you go left, like you go like from A to C, would that be minor?
Right. So this, if we don't know for sure that that is on a diameter,
Yeah.
then we wouldn't know for sure if it's a semicircle. But if it's a minor, if
would
it was,
that be a minor?
it would be a minor arc. It's close to a semicircle, but then if we went the other way, it would be a major arc.
Is DBE work?
DBE, yeah, we could name the semicircle DBE. The middle letter just tells us basically which direction we're going around the circle.
Oh.
The middle letter tells us which direction we're going. So I started D, here I'm going through point A and stopping at point B. Here I'm starting at point D, going through point C and stopping at B. And I could also go the other direction. I could say arc ECD or EBD. Either direction works. All right, so let me label a major arc. So I'm going to do a highlighter kind of around the outside. So I'm going to go here. Go around. So I have a major arc, ACE. So I start at A, go through point C, and stop at point E. So that would be a major arc, ACE. I could also call it ADE. And there are several major arcs that we could talk about here as well. I have a major arc, BBC, or CED. Any of those would be major arcs. The letters, when we talk about a major arc, tell us where we start, which point we go through, and where we end. So questions on our picture here. We know about major arcs, minor arcs, and semicircles. All right, so we know about segments. We know about our arcs. Well, one thing that we always want to do in math is we want to measure. We want to know how long. We want to be able to put a number to things. So we're going to talk about how we measure arcs. We're going to measure arcs in two different ways. So the first way has to do with degrees. So that's what we're going to talk about next, is the degree, how we measure arcs. So we know what arcs are, now we want to measure them. Well, when we're talking about degree measure, degrees have something to do with angles. So, and that's that's one way we're going to talk about arcs, is we're going to relate them to angles. So we need to talk about an angle in a circle. A central angle. We've talked about central angles a little bit when we talked about polygons. Well, central angle just means its vertex is an angle with its vertex at the center. So that's what we're talking about when we talk about a central angle. The central angle goes out and meets the circle. The arc that that angle makes when it meets the circle is called the intercepted arc. So the intercepted arc is an arc with endpoints on the sides of a central angle. So we'll draw a quick picture here. Here's our circle and our center. And we'll label these points. We have the center is A. So angle BAC is a central angle. And arc BC is the intercepted arc. So we know what our central angle is. We have an intercepted arc, just where the sides, the arc where the sides of the angle meet. They meet the circle. So now we know what the central angle is, we know what the intercepted arc is, we can talk about the degree measure of the arc. So questions on central angle and intercepted arc? All right, so we're going to use the central angle to measure our arc. The degree measure of a minor arc is the measure of the central angle. So if this arc, if angle BAC was 57 degrees, we would say arc BC is a 57 degree arc. So the degree measure of a minor arc is the same as the central angle. The degree measure of the major arc to find the degree measure of the major arc, we know that there are 360 degrees in the entire circle. So if we know the minor arc, to find the major arc going the other direction, we subtract from 360 degrees. So the degree measure of the major arc is 360 degrees minus the degree measure of the minor arc. So if this, we figured out that this arc was 57 degrees. To figure out the arc going all the way around here, we would do 360 degrees minus 57 degrees to figure out the major arc. Yes? Quickly. All right, so knowing how we're going to measure our arcs, what would be the degree measure of a semicircle? Half of 360, which is 180. So a semicircle, the degree measure of a semicircle is 180 degrees. Halfway around the circle has to be half the number of degrees in the circle. If we divide a circle into a whole bunch of different arcs, what do all the arcs, if we go all the way around the circle, what do all the arcs have to add up to? 360. We go all the way around the circle, all the arcs all the way around the circle have to add up to 360 degrees. So if we chop it up, no matter how we chop it up, all the arcs all the way around have to add up to 360. In a semicircle, we chop a semicircle up in a bunch of pieces. All the arcs in a semicircle have to add up to 180 degrees. So, kind of the way we would think about these things intuitively. But our minor arc, the degree measure of the minor arc is the same as the degree measure of the central angle. All the angles in a circle add up to 360, so all the arcs, we chop the circle up, have to add up to 360. Questions on degree measure? All right. We have a couple of things left to talk about. There's a lot of information, like I said. We have another way to measure arcs. We can talk about how many degrees are in the arc, but another way we want to measure them is the length. How long are they? So we want to figure out how we measure the arc length. We have degree measure, has to do with the central angle. Now we want to talk about the arc length. For arc length, we're going to say R is the radius of our circle. M is the degree measure of the central angle. And L is our arc length. We have a formula for arc length. L equals M divided by 360 times 2 pi r. So there's our formula for arc length. Well, let's talk about this formula for a minute. Seems kind of complicated. There's a couple different parts, but it's really not that complicated. What does 2 pi r tell us about a circle? 2 pi r is a circumference. Move that over so I have room here. And the circumference is how far it is all the way around the circle. So we could think of that as the arc length of the entire circle. That's how far it is all the way around. What is 360 degrees for a circle? Isn't that how many degrees are in a circle all the way around? So if we take the angle that we have and divide by 360, that tells us what portion of the circle that angle takes up. So m over 360 tells us what part of the circle we're talking about. So we're multiplying the part of the circle that we have by the distance all the way around, and that tells us the length of the arc that we're talking about. So 2 pi r is the distance all the way around. This is what part we're talking about. So we multiply what part we're talking about by the whole length, and that tells us the arc length of the arc that we're talking about. So it's really not that complicated a formula. We're just dividing up the circumference based on how big of an angle we're talking about with our circle. So let's look at a quick example of calculating an arc length. So we want the length of arc AB, and here's our circle. There's A, there's B, this is 40 degrees, and we have 16 millimeters for the radius. So this one should be an easy problem. We're just plugging into our formula. The arc length, L, the central angle, M, is 40, divided by 360, times 2 pi times 16. And I'm just going to plug this into my calculator. With this one, it doesn't matter what order I do it in. I could put 40 divided by 360, and then multiply by 2, and then multiply by pi, and then multiply by 16. I can multiply 16 by 2 by pi, divide by 360, multiply by 40. I can do it in any order, and we would get the same answer. And this comes out to, when I plug it into my calculator, about 11.17 millimeters. Questions on that example? All right, what would we do if we had a problem that says that our central angle is 38 degrees, the arc length equals 53 centimeters, and we want to find the radius? How would I go about solving that problem? Anybody have an idea? Well, we have a formula for arc length, right? We have this, but we already have the arc length. So what have we done in the past when we have part of the formula but not another part? Plug everything in, right? Solve for the part that we don't have. So this is the same thing. We've done this kind of problem quite a few times this year. We're going to plug everything we have into the formula, solve for the part that we don't have. So we know the arc length, 53, equals the central angle divided by 360 times 2 pi times r. And I'm just going to solve this equation for r. I've plugged everything that I had into my equation, and I'm going to solve for r. So what I would do, first things I think of doing here is I'm going to multiply both sides by 360. I want to get that 360 out of the denominator. When I multiply by 360, those go away. 360 times 53, I get 19080. And that equals 2 pi r. And 2 pi... Oh, 38. 38 times, thank you. 38 times 2 pi r. Now I'm going to divide by 38. I wanted to get rid of that 38 too soon. So divide that by 38, and I get 502.11. Two and pi are both multiplying the radius, so I'm just going to divide both sides by 2 pi. Those cancel, and I finally get r equals, when I divide 502.11 divided by 2 times, and I'm just going to use 3.14, I get 79.95. And my answer would be in centimeters. So I just plugged in everything I had into my formula, solve for the part that I don't have. Question on that problem? Okay, one last thing to talk about today. This one's very quick. The chords and arcs theorem. So this is, yes, in 71. I told my last class, when I was a sub, there was a teacher at one school that I subbed at, and she said in the spring, her students would always ask when we have class outside, she'd just say, let's have a vote, who wants to have class outside? And everybody would raise their hand, and she says, sorry, not a democracy. So anyway, Chords and arc theorem. In a circle, or two congruent circles, the arcs of congruent chords are congruent. Really, the chords and arcs theorem, pretty easy idea, and it's easy to see when we draw a picture what we're talking about. So here's my circle. I have two congruent chords. So these segments are congruent. And I'm going to call this A and B and C and D. So AB, segment AB is congruent to segment CD. So arc AB is congruent to arc CD. So that's all the chords and arcs theorem tells us. Is that if I have two congruent chords, then the arcs that share the endpoints of the chords have to be congruent also. And this will come up a lot in this chapter. When we have congruent chords, we have congruent arcs. All right, questions on the chords and arcs then? Okay. See?